The Super El Niño is about to peak, and scientists are now giving a genuinely worrying timeline for exactly when the worst of it is likely to hit, information that is already reshaping how governments, farmers, and emergency planners across the world are preparing for the months directly ahead. What began as a routine seasonal forecast update just a few months ago has rapidly escalated into one of the most closely watched climate stories of the year, as model after model continues trending toward the same unsettling conclusion that this event is not just going to reach historic strength, but is going to do so faster and more intensely than almost anyone initially expected. To understand why the timing of this peak matters so much, it helps to understand how El Niño events typically behave. El Niño refers to a naturally occurring climate pattern centered in the tropical Pacific Ocean, one that recurs every 2 to 7 years as weakened trade winds allow unusually warm water to spread across a massive stretch of ocean near the equator. These events do not simply switch on and off instantly, but instead build gradually over months before reaching their maximum intensity, typically sometime in late autumn or early winter, then slowly weakening again over the following months. Understanding exactly when that peak arrival matters enormously for forecasters, since the weeks surrounding an El Niño's maximum strength are consistent when its influence on global weather patterns becomes most pronounced and most disruptive. According to the latest specialized forecasts, this year's event is now trending toward peaking somewhere between November 2026 and January 2027, with sea surface temperature anomalies potentially reaching between 3 and 4 degrees Celsius, above average in the key monitoring region of the equatorial Pacific. That range would place this event among the strongest ever recorded using modern satellite-based monitoring, and some of the most recent ensemble forecasts pooling data across multiple leading climate models now suggest a consensus peak intensity around 3.6 degrees Celsius above average, a level that several research teams say could make this the strongest El Niño ever documented in the reliable satellite record dating back to the late 1970s. What has genuinely alarmed climate scientists is not simply the projected strength of this event, but how quickly it has developed relative to previous Super El Niño years. Only 3 events have reached that super classification since satellite monitoring began, occurring in 1982 to 1983, 1997 to 1998, and 2015 to 2016. According to detailed comparative analysis, the current event has already surpassed the development pace of the 2015 Super El Niño, at this exact same point in its life cycle, easily exceeding the peak intensity that previous event ultimately reached even this early in the season. When a climate pattern is outpacing the fastest developing event on record this far ahead of its expected peak, it signals a level of atmospheric energy building in the system that forecasters describe as genuinely unusual, even by the standards of a phenomenon already known for producing extreme global weather disruption. The timeline itself carries direct consequences for how governments and emergency agencies are choosing to prepare. Since the event is expected to reach its maximum intensity sometime between November and January, that window represents the period when the most significant global weather disruptions are likely to materialize, including G-altered storm tracks, shifted rainfall patterns, and the kind of extreme temperature anomalies that have historically defined previous Super El Niño winters. World Meteorological Organization Secretary General Celeste Saulo has been explicit that El Niño conditions are already firmly underway and that continued strengthening will meaningfully intensify the risk of both drought and heavy rainfall extremes, alongside heightened risk of both land-based heat waves and marine heat waves across ocean regions worldwide, a warning that has already prompted multiple governments to begin drafting contingency plans well ahead of the projected peak. If you're finding this breakdown genuinely useful, take a moment to like this video and subscribe, because the specific mechanics behind how this event builds toward its peak reveal exactly why the coming months carry such significant risk. At the physical heart of every Super El Niño lies a process scientists sometimes describe as a massive pressure release valve for accumulated warm water and stored thermal energy beneath the surface of the Pacific Ocean. In ordinary years, warm water tends to build up gradually in the western Pacific, essentially storing up heat beneath the surface over an extended period of time. As a Super El Niño approaches its peak, that stored warm water surges dramatically eastward and rises to the surface, releasing an enormous quantity of accumulated heat directly into the atmosphere within a relatively compressed time frame. This mechanism explains why the specific months surrounding an event's peak tend to produce such an outsized influence on global average temperatures, since the atmosphere is effectively absorbing months or even years of stored ocean heat within a matter of weeks. That surge in heat release carries direct implications for how likely 2026 and 2027 are to become record-breaking years globally. Climate researchers have already indicated it remains very likely that this year will rank among the 5 warmest ever recorded, even before fully accounting for the additional warming influence this developing El Niño is expected to contribute as it continues strengthening toward its projected peak. Because that peak is now trending toward the November through January window, forecasters expect the most significant temperature anomalies to emerge specifically during that stretch, meaning the timeline scientists are now describing effectively marks out the exact months when global average temperatures are most likely to reach genuinely unprecedented territory. For North America specifically, forecasters are pointing to a distinctive atmospheric pressure pattern already becoming visible well ahead of the official peak. Analysis of current fall 2026 pressure anomalies already shows what meteorologists describe as a strikingly clear, almost textbook El Niño signature typically associated with the depths of winter rather than autumn, featuring a low pressure zone across the North Pacific, a ridge of high pressure building over western Canada, an active subtropical jet stream pushing across the southern United States, and a paired low pressure pattern spanning the Atlantic and Europe. The fact that this pattern is emerging so clearly well before the event's official peak has led some forecasters to suggest the most disruptive atmospheric impacts could begin appearing earlier in the season than the ocean temperature timeline alone might otherwise suggest. Some of the more concerning secondary signals emerging alongside this timeline involve the stability of the polar vortex heading into winter. Specialized long-range analysis tracking early season indicators has identified a developing stratospheric high-pressure anomaly building around the core of the polar vortex, a pattern historically associated with weakened or displaced polar vortex conditions during Super El Niño winters. A weakened or displaced polar vortex does not guarantee any single specific regional outcome, but it has historically correlated with an increased likelihood of sudden, disruptive cold air outbreaks reaching further south than usual across parts of North America and Europe, even during a winter whose overall seasonal average trends warmer due to the broader influence of El Niño itself. Forecasters tracking this signal note that if the pattern continues developing as currently projected, the risk of a significant polar vortex disruption could become clearer within the next several weeks as the event approaches its peak. California and the broader western United States have drawn particularly close attention given the well-documented historical relationship between strong El Niño winters and extreme precipitation events. Detailed statistical analysis of the observed relationship between strong El Niño events and extreme daily precipitation extremes shows a particularly robust connection when researchers apply more dynamic, updated measurement indices rather than older, traditional approaches. If this event follows, the pattern established by previous strong to super El Niño winters, meaningfully elevated flood risk could begin materializing across California, specifically during the same November through January window when the broader event is expected to reach its maximum intensity, a timeline that gives state emergency planners a relatively narrow window to finalize flood preparedness measures before the most significant risk period arrives. Beyond North America, the projected timeline carries significant implications for regions across the southern hemisphere as well, since El Niño's influence extends well beyond the Pacific Basin itself. Parts of Australia and Southeast Asia have historically experienced significantly reduced rainfall during Super El Niño winters, raising early concerns among agricultural planners in those regions about potential drought stress arriving during the same November through January window when the event is expected to reach peak strength. Meanwhile, parts of Eastern Africa and South America have historically seen the opposite effect, with strong El Niño events correlating with significantly elevated rainfall and flood risk in specific regions, illustrating just how differently this same underlying climate pattern can manifest depending entirely on geography. Emergency planners and insurance analysts across multiple continents have already begun factoring this narrowing timeline into their own preparations. Utility companies in regions historically affected by El Niño-driven storms have started reviewing grid resilience plans well ahead of the projected peak. Since past Super El Niño, winters have repeatedly demonstrated how quickly a single severe storm or unexpected cold outbreak can overwhelm infrastructure that performs perfectly well under more typical seasonal conditions. Agricultural planners across both drought-prone and flood-prone regions face a similarly complicated task, since the same overarching climate pattern can simultaneously threaten one region with dangerous dryness while threatening another, with destructive flooding, sometimes within the very same growing season and the very same narrow window of peak intensity. Global shipping and aviation industries are also watching this developing timeline closely, given how significantly past Super El Niño events have disrupted storm tracks and jet stream positioning across major international travel corridors. A more active subtropical jet stream pushing across the southern United States, combined with a reshaped storm track spanning the Atlantic and Europe, has historically translated into more frequent flight delays, rerouted shipping lanes, and increased insurance costs tied to weather-related disruptions during previous strong El Niño winters. Because this year's event is trending toward both greater intensity and a relatively compressed timeline for reaching that intensity, industry analysts are treating the November through January window as a period requiring heightened operational readiness across multiple sectors simultaneously. Scientists have also been careful to note that the timeline itself remains subject to some degree of uncertainty, even as model agreement has grown increasingly strong in recent weeks. Seasonal forecasts of this kind describe probability distributions rather than fixed certainties, meaning the actual peak could still arrive slightly earlier or later than the current November through January window suggests, and the eventual peak intensity could still shift somewhat as additional ocean temperature data becomes available in the coming months. That said, researchers emphasize that the consistency across independent forecasting approaches, ranging from dynamical ocean models to historical pattern comparison to atmospheric pressure analysis, gives this particular timeline considerably more confidence than a typical seasonal outlook would normally carry this many months before an event's projected peak. What makes this particular timeline so genuinely worrying to the scientists tracking it is not any single data point in isolation, but rather how consistently multiple independent lines of evidence keep pointing toward the same conclusion. Ocean temperature models, historical comparison data, atmospheric pressure pattern analysis, and even early polar vortex indicators are all converging on a narrow window between November 2026 and January 2027 as the period when this event's impacts are likely to become most severe and most widespread. That level of agreement across such different types of analysis is relatively uncommon this far in advance of an event's peak. And it is precisely why researchers are treating the coming months with a degree of urgency typically reserved for events already confirmed to be historically significant, rather than waiting for that significance to become undeniable only once the peak has already arrived and the most disruptive impacts are already underway. If this breakdown of exactly why scientists are watching this specific timeline so closely helped clarify what the coming months may actually bring, make sure you are subscribed. Because with ocean temperatures still climbing and every model still trending toward record territory, this is a story that is likely to keep developing right up until that peak finally arrives.